try to solve it yourself. So Mn is equal to intersection points. For example, this function, the intersection point will be 4, so it is 4. And this line, the intersection point is 5, so the Mn is 5. And this other line, the intersection point is 6, so it is 6. We need to find the Mn of each A, B, C, D. Let's try to solve the A one first. Y equals log base 1 out of 4 of x. Because this is a logarithm, we know that the x has to be greater than 0. And we can change the base into like this, and if we put out the -1, the logarithm will be shown like this. Let's put in some examples and try to draw it. If we put in x equals 4, y will be -1. And if you put in x equals 1, y will be 0. And if you put in x equals 1 out of 4, y will be 1. So if we draw this logarithm, it will be drawn like this. So the intersection point, Mn, will be shown like this, and the intersection point of A will be 6. Moving on to the next question. Let's try to draw B. Y equals 3 to the power of x. And let's similarly put in x equals 0, y equals 1, x equals 1, y equals 3. And let's try to draw it, and it will be drawn like this. Because of that, we know that the intersection point of B will be 6. So the Mn of B will be 6. Next one. Y equals 3 out of 2 times x plus 2. As we have done it before, let's put in some values. When x equals 0, y is 2. X equals -1, y will be 1 out of 2. Because of that, it will be drawn like this, and we can say that the intersection point of this line and the circles will be 4. So the intersection point of C will be 4, which means Mn is equal to 4. But wait, this may not be true. We have just drawn the perfect circle from the computer, so we know that it is 4, but it may be tangent to the circle or go through this circle. So what we have to do is prove that it doesn't go through the circle or it is tangent to it. So let's put a line that is tangent to the circle and put y equals 3 out of 2 x plus k. And this circle is x squared plus y squared equals 1. Let's substitute this line's equation into the circle's equation. And if you put out the y's in it, it will be shown like this. Because this line and this circle is tangent to it, the discriminant of this quadratic function is equal to 0. So let's put in the values for the discriminant, and it will be shown like this. And if you calculate it, it will be shown like this. Because of that, 4k squared is equal to 13, which means k squared is equal to 13 out of 4, which means k is equal to plus minus square root of 13 over 2. You can see that k has two values because 2 line is tangent to this circle, having the gradient of 3 out of 2. Because we need to only compare the upper one is square root of 13 out of 2. Because the gradient is the same, we need to only compare y-intercept. So we need to compare 2 and square root of 13 out of 2. Let's suppose that 2 is greater than square root of 13 out of 2. If you multiply 2 on each side and square it, 16 is greater than 13. Because this is correct, 2 is greater than square root of 13 out of 2. Because of that, this line is in the upper side of the tangent line, and which means the intersection point is 4. So Mn of c is 4. Last but not least, y equals square root of 3x plus 3 minus 2. Because the inside of the square root has to be greater than or equal to 0, 3x plus 3 has to be greater than or equal to 0. So the starting line would be x equals minus 1. So let's put in x equals minus 1 in it. Then y will be minus 2. If we put in x equals 0, y will be minus 2 plus square root of 3. Because the approximation of square root of 3 is 1.73, I miswrote this, sorry. The y will be the approximation of minus 0.29 something. The important thing is that it is greater than minus 1. We can also put in x equals 1 in it and put in the value of square root of 6, but because we know how this square root function will be drawn, we can just draw it. So the intersection point of D will be 5. So the Mn of D will be 5. The answer will be A equals 6, B equals 6, C equals 4, and D equals 5.